Alright, we have this electrical system, and I am going to propose now that we use what I call the direct method to generate models of electrical systems, which is even a simpler version of what we had seen before. What we're going to do, so that I'll give you a heads up, is to draw the bone graft model right on the system, on the electrical circuit. So to do that, the very first thing we gotta do is to recognize the elements in here, what we have, and then we are going to use the step number 2 in here. We'll say we're going to use a one junction for each distinct current. Okay. So I'll just put this good in here and then correct and make sure that we write correctly. So in here we are, for this particular system, we need to do a bit of a recognition here of this side. In here, when you have this open-ended circuit in here, either you could interpret as you don't have any elements in here, or the way I would prefer is that you interpret it that you have a voltmeter in there, that you are measuring something. So I would just sort of pencil in, or maybe draw it this way. This is like having a voltmeter in there, you know, some measuring device. Now, remember one thing: a voltmeter is a device with current of the voltmeter equals to 0. Yeah. So what I'm going to do is go to the next step in here. What I would do is I'm just going to go and use a red pen so that I do the representation of what I just said. In here we're going to see a one junction for the current I sub 1, which would be the current that circulates like that, right? I'm just going to do a one junction for current I sub 2, which is a current that goes this way. And I will do one for current I sub 3 the same way. And although this is a 0 current, I am also going to do that. This is a call it I voltmeter equals to 0, but I'm still going to put it in there as if it would be part of the system. But the only reason that I'm doing that is to add some element that would actually represent this measurement. That's the only reason. I'm not changing the system in any way. And in a way, it's giving me more of a mapping here that I can go by and understand the circuit better. So step number 3 in here, as we are going to see, is we'll say step number 3 is you could say attach the elements that see or that experience and those currents. Okay, so we're gonna see this in here. Over here we're gonna go and directly say this is the voltage source with this, you know, source of effort with voltage V. Alright, so I attach that element. In here I could attach this one too. This is an R element with value R sub 2. Yeah. And in here I would do this. I would like to attach a source of flow in here with you know, this way with this would be I of b is equals to 0. Okay, but because one of the signals is 0, we use this symbol called an activated bond to indicate exactly this. Okay, so you can see that very clearly this R1 is in between I1 and I sub 2. So this clearly sees the difference between those two. And so what I would, so that we don't interfere directly with it, or maybe it's a good idea to do it right on top of the element, but I'm going to try to do it next to it so that we don't lose the interpretation of this and it becomes crowded. So step number 4 would be use a 0 junction to represent the current differences, right? These differences are also represented with a one junction, with one junctions. Okay, let's correct this, and of course this other one too. And so what am I trying to say here? So I represent the difference in here. So this one in here, this became a little, yeah, okay. So this difference in here with the 0 in here, like that, is represented with a 1, which indicates I1 minus I sub 2. Okay, the difference between these two, I1 and I sub 3, obviously you could do it like this. See, you could do it this way. And then this difference is also a 1, that is I1 minus I sub 3. And between these two also, here this would be 0, and between this will have a 1 in here, which indicates I sub 3 minus I sub 4. Okay? And so we do this, we have done step number 4. I think step number 5 would be attach the elements that experience those current differences. Okay, so if this is the case, you can see that see the difference between this and this. So that would be the R element with value R sub 1. Then we have in here the difference between this and this is seen by this capacitor. Here we'll put the value with C sub 1, and this other one would be the C sub 2. Yeah, and that's about it. I don't think that we have any other. There's no element in between here, and there's no. This is in fact the end of our bond graph model. We have basically finished this. We could simplify this a little bit if we want to, but we don't need to really. I mean, when you put this model into CAMG, it would actually generate a computer simulation without any problem. So I think we have attached the elements that see those differences, and then you could write in number 6, we could say check power flow, and then you could say comma causal marks. I would say this is optional if using CAMG, because the computer program will actually assign it for you. And then you can say also simplify. This also is optional. How is that? In fact, yeah. Now, I like to see those 6 steps and be done with it. I think on the 6th step in here, where we assign the causal marks, it would be the now. We could leave the bone graft model right on the system and go on with it, or simplify it if we wanted to, but like I said, this is optional. Perhaps just so that you would see a simplified version of this, we could draw it down here, but again, it's not necessary. I think it might be better to concentrate on the assigning the causal marks on this, just again to check it out and practice that, not because if you're using CAMG you don't really have to do that. So I am going to change colors and maybe use the a green pen to do it. This is the assignment of the causal mark here for the source, and then we use the this one we have already done, and in here we could use an integral form for the C element, which makes this to be like this. And the moment the C is like this, these ones have to be like this, because the 0 can only take one effort, the others have to be away. So in here you have we have this flowing here, so this one has to be like this. If we put this in integral form, then this has to be like like this. If this determines the effort here, then it makes this like this. And we have a little bit of a conflict in there. Let me see what are we doing here. Okay. The reason is because this is the same thing, you know, this 0 and this is the same thing. It really doesn't exist. But I believe that we need to in this we need to make a slight correction in here, because I did not quite propagate the causality correctly here. So let me go to where it says draw, and what we need to do is, once I put this in integral form, I had to set it up for this, but also I forgot to set it up on this end. So that's the problem. So this one in here, and we need to erase it. So I will do that in here. So we need to correct this. Okay, so if it is like this, You see what it does to the one right there? This, it makes this to be like this. What did I just do? I changed colors inadvertently. I want to be consistent with it. Sorry, let me just go back. Green. Green now is like that. It's not green. What am I seeing? I'm not seeing green here. I'm so blue. But it's gotta be right. Hold on for a second. There we go. So this is green. Okay, very good. So it had to be like this. And the moment that I did that, this guy has to be like this, and this has to be like this, which makes this C in derivative form, which is the way it needs to be assigned. So in here, this in here will be this way. So this is, it needs one flow in here, and when we do that, these two are like this, and then makes this like that, and in this case makes it like this as well. So this is the final bond graph model with power flow and causality completely. Like I say, you could simplify it if you want, but that is an optional step. I'm emphasizing that that is an optional step, and then we would have to draw it outside of the system, and the exercise here was to draw it on the system, so let's leave it like that.